Hello everyone, welcome back to our channel gsipucmysuru. This is the next session from the same chapter, that is Principles of Electricity, Network Theorems and AC Principles. In the last session we saw what exactly is maximum power transfer theorem. In this session we will be solving some of the problems on the same topic. So let's begin with the very first problem. So this is the first problem where you have to find the value of load resistor RL in figure for the maximum power transformation. So for maximum power transformation, we know that RL must be equal to R Thevenin. Only then the maximum amount of power will be transferred from the source to the load. So resistor RL for maximum power transformation and RL equals R Thevenin agirodrinda we have to find out this R Thevenin. So we know that in order to find out this R Thevenin from Thevenin's theorem, we have to we have to remove the voltage source by replacing it with its internal resistance. So the internal resistance of a voltage source is equal to 0 agirodrinda we are just going to short that voltage source. So the next step what we are going to do is we are going to remove this load resistor, and across that we are going to measure what is called as R Thevenin. So the new diagram in order to find out R Thevenin will be like this, where we have shorted the voltage source, or we have replaced the voltage source by its internal resistance, and the other resistors will be retained by removing that load resistor. So the resistance across these two ends will be named as R Thevenin, what we have to find out in this particular problem, so that the maximum power will be transferred from the source to the load. So the value of this resistor is 1K and this is also 1K, whereas this is 100 ohm. So I have already told you that whenever you want to find out the equivalent resistance across any two terminals, observe the diagram from the opposite end of that side. Then from this end, try to analyze the resistors or try to analyze the connections of the resistor, whether they have connected in series or parallel. Accordingly, solve the problem. So we know that 1K and 1K, these two are connected in series. So after solving this, we will be left with only one single resistor whose value will not be equal to 1K, and these two resistors will be connected in series. So R Thevenin will be equal to, these two are connected in parallel, 1K parallel with 1K, and that combination is in series with 100 ohm, so plus 100. So 1K parallel with 1K, I am having only two resistors which are connected in parallel. So let me use the direct formula, 1 into 10 to the power of 3 R1 R2 divided by R1 plus R2. 1 into 10 to the power of 3 into 1 into 10 to the power of 3 divided by 1 into 10 to the power of 3 plus 1 into 10 to the power of 3 plus 100. So 1 ones are 1. 1 into 10 to the power of 3, let me retain this 10 to the power of 3 as it is, and 1 plus 1 gives me 2 into 10 to the power of 3. So 10 power 3, 10 power 3 gets cancelled. So here I will be left with plus 100. So 1 divided by 2 gives me 0.5 into 10 to the power of 3 plus 100. But 0.5 into 10 to the power of 3 gives me 500 plus 100. So the total of these two values is 600 ohms. So R Thevenin is equal to 600 ohms. So this implies that if the value of this load resistor is chosen as 600 ohms, then maximum amount of power will be transferred from the source to the load. So if RL value is equal to R Thevenin, maximum amount of power will be delivered to the load. So in this problem, the value of the load resistor RL must be equal to 600 for maximum power transformation. Now we'll move on to the next problem. So this is the second problem where you have to find the value of load resistor RL in figure for maximum power to be transferred and calculate the maximum power transferred to the load. So in order to transfer the maximum power to the load, RL must be equal to R Thevenin. So in the first part of this problem you have to find out R Thevenin. After finding out R Thevenin, you have to calculate the maximum power transferred to the load. So let us denote that by PL. You have to find out R Thevenin and PL. So in order to find out R Thevenin, you have to remove this load resistor, the voltage source, and replace it with its internal resistance and remove that RL. So the new diagram in order to find out R Thevenin will be like this. This is shorted 1K, 1K, and at these two ends we are going to measure the R Thevenin resistance. 1K, 1K, this is also 1K, 2K and 1K. So if you look from this end, this 1K and 1K are connected in series. So series and the hendaga 1K plus 1K gives me 2 kilo ohm. So the new diagram of this diagram will be like this. This is equal to 2K. Now this 2K and 2K are in parallel combination. So 2K parallel with 2K gives me 2 into 10 to the power of 3 into 2 into 10 to the power of 3 divided by 2 into 10 to the power of 3 plus 2 into 10 to the power of 3. So I will be getting this as 2 plus 2 is equal to 4, 2 into 2 is also equal to 4, 4 into 10 to the power of 3 into 10 to the power of 3 divided by 4 into 10 to the power of 3. I am taking 10 to the power of 3 as common factor and adding this 2. So 10 power 3, 10 power 3 gets cancelled, 4 ones are 4 ones are. So I will be remaining with 1 kilo ohm. So in place of these two resistors, I can write a single resistance or a resistor whose value is equal to 1 kilo ohm. Now if you look into this particular diagram, 1K, 1K and 1K are in series. So R Thevenin equals 1K plus 1K plus 1K, which is equal to 3 kilo ohms. So R Thevenin gotaitu. Now you have to find out PL, that is the maximum power of the load. We are having this formula PL, which is also equal to P max, is equal to V Thevenin square divided by 4 RL. But this RL can be replaced with R Thevenin. So V Thevenin square divided by 4 R Thevenin. So this is the formula. We have found out this R Thevenin, but I don't know the value of V Thevenin. So let us now find out the value of V Thevenin for this particular problem. So R Thevenin value is equal to 3 kilo ohms. Let us erase all the other things. Now the new diagram will be like this. 8 volts, here 1K, 1K. We will be having two resistors here. This is a 2 kilo ohm and the voltage across these two ends is nothing but V Thevenin, which is open circuited. So this V Thevenin is same as the voltage across this 2 kilo ohm resistor. So this is 1K, 1K and this is equal to 8 volts. Now if I am going to consider this particular loop, we are going to apply the voltage divider rule. Then V Thevenin equals the voltage source 8 into the resistance across which I am measuring the voltage, that is equal to 2 kilo, 2 into 10 to the power of 3 divided by sum of all the resistors present in that loop. 1K plus 2K plus 1K, that is equal to 4K, that is 4 into 10 to the power of 3. 10 power 3, 10 power 3 gets cancelled, 4 ones are, 4 twos are, so 2 twos are 4. V Thevenin is equal to 4 volts. Now you can easily substitute the value of V Thevenin and R Thevenin in that PL or P max and find out the load power. So V Thevenin square divided by 4 R Thevenin. So V Thevenin value is equal to 4 square anta helidaga, let me write it as 4 into 4 divided by 4 into R Thevenin value is equal to 3 kilo ohm. So 3 into 10 to the power of 3. So 4 gets cancelled. So PL is equal to 4 divided by 3, 1.33 into 10 to the power of 3 is in the denominator. When it goes to the numerator, it will be 10 to the power of minus 3 and the unit for power is watts. So PL is equal to 1.33 milliwatts. So this is the final answer what you are asked to find out in this problem. So R Thevenin value, find the value of load resistor RL for maximum power to be transferred, that is equal to 3 kilo ohm, and calculate the maximum power transferred to the load, that is equal to 1.33 milliwatts. Clear? Now we will move on to the next problem. So this is the next problem where you have to find out the value of load RL to abstract maximum power from 12 volts battery. So they have given 12 volts battery. So from this 12 volts, what will be the maximum amount of power that will be abstracted by this load resistance that you have to find out, which is nothing but R Thevenin. You have to find out R Thevenin. Hence determine the power transferred. So you have to also find out PL. So R Thevenin, and also we have to find out V Thevenin. Only then we will be able to find out this PL. So let us first find out V Thevenin. For that, what we are going to do, we are just going to remove this load resistor, and the voltage which is measured across that terminals will be named as V Thevenin. So the new diagram for finding out V Thevenin will be like this. So the voltage which is measured across these two ends will be named as V Thevenin. This is 19 kilo ohm, this is 9 kilo ohm, and this is equal to 12 volts. So the V Thevenin voltage is same as nothing but the voltage which is measured across 19 kilo ohms. So we are going to apply voltage divider rule. According to that voltage divider rule, V Thevenin equals 12 into the resistance value across which I am measuring the voltage, that is 19 kilo, 19 into 10 to the power of 3 divided by sum of the resistors which are present in that particular loop, that is 9 kilo plus 19 kilo. So V Thevenin will be equal to 228 into 10 to the power of 3 divided by 28 into 10 to the power of 3. 10 power 3, 10 power 3 gets cancelled. Then V Thevenin will be equal to 228 divided by 28, whose value is equal to 8.142 volts. So we have found out this V Thevenin value whose value is equal to 8.142. Now you have to find out R Thevenin. So in order to find out R Thevenin, we are just going to remove this voltage source and replace that voltage source with its internal resistance. So this is a simple diagram. The resistance across these two ends is called as R Thevenin. This is equal to 19 kilo. This is equal to 9 kilo. So R Thevenin is equal to 9K and 19K are connected in parallel. So 9 kilo parallel with 19 kilo. So R Thevenin equals 9 into 10 to the power of 3 into 19 into 10 to the power of 3 divided by 9 plus 19 into 10 to the power of 3. 10 power 3, 10 power 3 gets cancelled. So 19 into 9 gives me 171 divided by 28. 171 into 10 to the power of 3 divided by 28 will give me 6.107 kilo ohms. So R Thevenin value is equal to 6.107 kilo ohms. Now you have to find out PL, where PL can be calculated using this formula, V Thevenin whole square divided by 4R Thevenin. We know that V Thevenin value is 8.142. So 8.142 whole square divided by 4 into R Thevenin value is 6.107 kilo. Kilo in the sense into 10 to the power of 3. So let us substitute this. Let us find out this answer. So 8.142 whole square will give me 66.29 divided by 6.107 into 4 is equal to 24.428 into 10 to the power of 3. So 66.29 divided by 24.42 will give me 2.714 into 10 to the power of minus 3 watts, or 2.714. PL is equal to 2.714 milliwatts. So this is the final answer for this problem. So they have asked us to find out the load resistance RL, whose value is equal to 6.107, and the power which is transferred, whose value is equal to 2.714 milliwatts. Clear? Now we'll move on to the next problem of this session. So the next problem is, according to maximum power transfer theorem, what should be the value of load resistance RL to abstract maximum power from the 16 volts battery? That is, they have asked us to find out the load resistance whose value can abstract the maximum amount of power from this source. So we have to find out RL, which is nothing but R Thevenin, for the first part of the problem. What is the value of this power? So what is the value of the power what is transferred from the source to the load? So PL, or which is also considered as P max, also should be found out in this particular problem. So we know that PL is equal to V Thevenin square divided by 4 R Thevenin. So V Thevenin as well as R Thevenin also we have to find out in order to find out this PL. So V Thevenin ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ we have to remove this load resistor, and the voltage across these two ends is named as V Thevenin. This is equal to 2 ohms, 6 ohms, 3 ohms, and this is equal to 16 volts. So you have to apply a voltage divider rule. So according to that, V Thevenin is equal to the voltage source whose value is equal to 16 into the resistance across which I am measuring the voltage. That is, V Thevenin is same as the voltage across this 3 ohm resistance. So 3 divided by 6 plus 3, that is the sum of the resistors which is present in that loop. Here in this loop I am having 6 and 3, so 6 plus 3. So 16 3 will give me 48 divided by 9. So 48 divided by 9 gives me 5.33 volts. 5.33 volts. So this is the value of V Thevenin. For the same diagram you have to find out R Thevenin. For that you have to replace the voltage source by its internal resistance. So the new diagram in order to find out R Thevenin will be like this, and the resistance which is measured across these two ends is called as R Thevenin. This is 3 ohms, 2 ohms and 6 ohms. When you look from this end, 6 ohms and 3 ohms are connected in parallel, and that parallel combination is connected in series with 2 ohms. So R Thevenin is equal to 6, which is in parallel with 3, and that combination is in series with 2. So 6 into 3 divided by 6 plus 3 plus 2. 6 3s are 18 divided by 9 plus 2. 9 1s are 9 2s are. So 2 plus 2, which is equal to 4 ohms. So R Thevenin is equal to 4 ohms. Now the load power or the maximum power which is transferred from the source to the load, that is denoted by PL, equals V Thevenin square divided by 4 R Thevenin. So V Thevenin value is 5.33 whole square divided by 4 into R Thevenin value is also 4. So 5.33 square will give me 28.4089 divided by 4 fours is equal to 16. So I will be getting the answer as PL equals 1.77 watts. Here I am not having into 10 to the power of 3 in the denominator. So PL is just equal to 1.77 watts. Clear? We will be moving to the next problem of this session. So this is the next problem where you have to find the following, that is total resistance, voltage at point A, potential at point B, total current flowing in the circuit. So the first one, total resistance. Total resistance ಅಂತ ಹೇಳಿದಾಗ in this diagram I am having 4 number of resistors whose values are equal to 1k, 2k, 3k and 4k. Here 3k and 4k are connected in parallel ಅಂತ ಹೇಳ್ಬೋದು. After solving that 3k and 4k which are connected in parallel, I will be getting only one single resistance whose value I don't know because I have not calculated that. Then that particular resistance and this 2k will be connected in series. So in place of these two, I will be writing another resistor. So let us understand this with the diagram itself. This is 1k, this is 2k, and 3k and 4k are connected in parallel. So in place of those two, I am going to write another resistance or another resistor whose value is equal to x. So this is B, right? Now this 2k and x are connected in series. So in place of these two, I am going to write a single resistor. Let me call that resistance as Y. Now this Y and the resistance which is present or the resistor which is present in this line or this wire are connected in parallel. I am not having any kind of resistance over here. So ಇಲ್ಲಿ ಯಾವುದೇ ರೀತಿಯಾದಂಥ resistance ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ I can tell that the resistance in this particular line is equal to 0. So we have seen that in the short circuit there the total resistance across the short will be equal to 0. So these two are connected in parallel ಅಂತ ಹೇಳಿದಾಗ y into 0 divided by y plus 0 ಅಂತ ಹೇಳಿದಾಗ anything multiplied by 0 will be equal to 0 itself. So this part, this complete part will be equal to 0. So the final diagram will be like this, where it will be having only one voltage source whose value is equal to 12 volts and only one resistor whose value is equal to 1 kilo ohm. So the total resistance, the part A, total resistance is equal to 1 kilo ohm. Clear? Now the second part is voltage at point A. Second one is voltage at point A. So voltage at point A ಅಂತ ಹೇಳಿದಾಗ from point B and point C the resistors are shorted. So I should not consider these resistors 2k, 3k and 4k na consider ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. So the total resistance in this particular part is equal to 0. So whatever the voltage I am applying from this 12 volts, that entire voltage will be dropped across this one single resistor whose value is equal to 1 kilo. So here they have asked us to find out the voltage at point A and ಹೇಳಿದ್ರೆ it is just equal to 12 volts only. So the voltage at point A is equal to 12 volts. Now the next part, that is potential at point B. Potential at point B. Now the potential at point B ಅಂತ ಹೇಳಿದಾಗ here since this A is connected to positive terminal and B is connected to, because all these resistance value is equal to 0, there is no use of connecting all these resistor in this manner when I am shorting these two terminals B and C. So the potential at point B can be considered as like this. Let us write a separate diagram. It can be considered like this, where this is equal to 12 volts, this is equal to A and this is equal to B. So the B potential is at negative potential of the battery. This is positive potential. So the voltage at point A is equal to 12 volts. The potential at point B is equal to 0 volts, because all these three resistors is of no use because we have shorted these terminals B and C. Finally, you have to find out the total current flowing in the circuit. So the total current is equal to V divided by R total. V is equal to 12 volts. our total is just equal to 1 kilo ohms because 2 ohms, 3 ohms and 4 ohms will be completely neglected. So 1 into 10 to the power of 3. So 12 into 10 to the power of minus 3 amps, or total current IE which is flowing in the circuit will be equal to 12 milliamps. So this is the final answer for the current flowing in the circuit. Clear? So in this session we solved some of the problems on maximum power transfer theorem and also a single problem on the basics of your principles of electricity. I hope you are very much clear with these problems. I will be coming soon with the next topic. Until then, take care. Bye bye.